Hi, my name's Hunter Kempf, and I'm a Z by HP Global Data Science Ambassador and a data scientist. I'm going to go through today an introduction to generative art with Stable Diffusion presented by HP. So, a quick agenda here for the topics we'll cover. First, we'll go over a model architecture overview, some ethical considerations, some practical considerations, then a getting started chunk, as well as kind of a more in-depth optimization chunk, and some workflow or some app examples. So first, we'll go through basically a general model architecture overview. And first, we'll look at a timeline here of basically from December 2017 when the first transformer model architecture was described in a paper. That was basically transformative to the way a lot of people did and thought about machine learning, and especially these large language models, and then turned into being applied also to image tasks as well. So attention is all you need was the first paper developed by folks at Google, and then BERT was kind of an implementation of that transformer architecture. Came out in 2018, and Dolly out of OpenAI was really that transformer architecture ideas applied to kind of a text image task, and Stable Diffusion was an open source version of that text to image transformer model, basically applied on images. And Stable Diffusion, as you can see here by the release date, is very, very new. So all the resources we're talking about, are out as of this year, and really, out as of a couple months ago. There's plenty of new versions and additional projects that are coming out kind of around supporting this initiatives as well. So, quick view at the attention is all you need paper and kind of the important stuff coming out of it. So, yeah, again, you can look at the title page of the paper here on the left, and it came out in December of 2017, and really mostly, folks from Google there working on that project. And on the right here, we have a view of kind of in a diagram what that uh, important transformer model architecture was. And really the important things to look at here are these multi-head attention blocks, as well as kind of the concept of an encoder block and a decoder block, which this here was applied for language tasks, and we'll see additionally kind of how these similar core concepts are added into some of the more visual tasks. So we can go here to the next one, which is high resolution image synthesis with latent diffusion models. This is really the paper that Stable Diffusion came out of. And again, we have kind of the cross attention here, and an encoder and decoder to the latent space. Very similar if we go back encoder and decoder. And yeah, the cross attention blocks we have really, you don't need to fully understand this to be able to use the model, but good to understand that concept of attention is basically throughout all these transformer models quite important. So now we've seen a little brief view of that model overview. We'll jump into here a section on ethical considerations. So really, for using any of these generative models, it's important to understand what they're trained on. And so the Stable Diffusion model here is trained on the LAION dataset. And this data set is basically a list of kind of indexes of web images with associated text to them. You can see uh, kind of print out visualizations here of some of the image sizes and the text length around it. And then up on the left over here, we can see kind of a view of some of those like images that can be pulled out through a clip retrieval tool. But really the important thing to maybe note here is that this data set is basically just an index of all of the images from the web. These are, pulled from, in this view, maybe something like funnycatsgif.com or any other website. So really it's making use of all this data on the internet, and the researchers who are pulling it really have to be careful to train their models using images they have the rights to, or that they're maybe that they should be using to try not to use copyrighted images. And I think this is really maybe where some of the gray area can come in of not every model will be trained on fully open in the public domain images. And so I think understanding that, and really, as you use the outputs of it, I think it's important to know, okay, if I put in exactly the right query for French cat, the right seed, the right blend of information, or hipster cat, or one of these things, I may come out with something that really resembles, or maybe almost exactly is one of these images. And that is a concern with transformer models, and I think something to be aware of if you're going to use these for any sort of generative art that you're planning on making money off of, and really trying, I think, to realize that point there of the training set being from kind of public images off the internet. And we could see this again here in another example would be the Stable Diffusion models have the ability to use an input image. And so here's a very simple example from the Stable Diffusion GitHub, where you see basically a single input image and generating kind of a couple lookalikes. The thought here around ethics would be, if this fairly simple drawing here was, say, a famous work of art, or another piece of art that an artist created, I think you really start to get into kind of a moral quandary or issues around using someone else's art, even if you've put kind of this filter on top of it. That's the Stable Diffusion model. You really should, for your input images, I think it's a little less of a gray area. The training data may be more, but these input images that you're using to kind of set the weights, the initializations of the model, really, should be stuff that you built yourself, or that is in public domain. So not taking someone's half-finished art, so let's say, and finishing it yourself. And so that leads us into a couple of examples of articles in the news around these ethical considerations. The first one here is around a user who took a half-finished drawing from someone that was doing a live stream of a drawing, and used a similar tool to Stable Diffusion to kind of finish out that model, and then came back and kind of was demanding credit from that artist that was working on it on the live stream. Obviously, this sort of concept here is really something that's like has no place really in the AI kind of generative art world because you're just stealing from that creator. You use, their input image, and that is their copyright, and then directly basically tried to finish and claim credit for it as your own original work. So that right there is a peak example of something that really is kind of wrong in the generative art space. So if you are just getting into it, I would say avoid anything resembling this, and really start your images from a text input or from your own source material. And another view here on the right, we can see a similar model, another transformer model where in this case a user's copyrighted content was basically regurgitated out from a transformer model with the copyright stripped out. And so I think this is another warning here of understanding the inputs that a model was trained on, because granted, I think it's a little more difficult in a visual view to have this similar pull out, but yeah, you could see basically his code on the left, and then what comes out of a transformer model that was trained on a bunch of code from GitHub on the right. And really, again, this is something that you as a user should have some level of concern about, but it's really more for those that are kind of fine tuning or training any of these models as to the inputs they're using and how they're used. And finally, here we'll go and see that really that concept of training sets for these sort of visual tasks in the public domain. People are having those conversations on where kind of where to draw the line. Obviously, as humans, we see a bunch of art and we can create something in the style of something else, and it's not an issue. But when an AI does it at scale, maybe it becomes a bigger issue. I think these are things that we're still, as a community and legally, determining and understanding. So practical considerations, now that we kind of have a brief overview of those ethical views, we can kind of jump into a couple of things on if you need to run this model, what are the minimum specs, maybe some good specs and some great specs for what your computer will look like. And for the Stable Diffusion models, they're pretty large in terms of the model footprint on your graphics card. And you'll see here we really are touching mostly on graphics cards, because the model should pretty much just be run on a graphics card. You can try to run it on a CPU. It'll be very slow, and that slowness will really hurt the creative process of working with these generative art models. So really the minimum specs would be something like a GTX 1060 with 6 gigs of video memory. Something good would be something like a 3080 Ti. Something great would be something maybe like an RTX A6000 with plenty of video memory, so you can run a bunch of these in parallel. And really, I think that's where these sorts of models get off and running really well, is something with around, let's say, 16 to 20 gigs or more of video memory, and you're really going to be able to use the model to kind of the fullest extent. And so basically for my use case, I am sponsored by Z by HP, and so I have a ZBook Studio and a Z8 G4. You can see basically some of the video cards that are in those for my machines, and basically want to say that I've tested this Stable Diffusion models on both those, and they work great. It's, I think, a very big plus, again, to have something like the A6000 in my desktop, really to basically make this workload run faster and just better in terms of, we'll see a couple things later where I ran basically 8 images in parallel, and in 40 seconds I have the output, instead of, if I'm running it on a CPU, it would probably be something on the order of 15, 20 minutes before I start to get one image. So really, GPU and bigger video memory are going to be really helpful for these sorts of tasks. So we'll look again here at the Z by HP lineup. And if you want to do this on one of the Z by HP laptops, I'd suggest a ZBook Studio or a ZBook Fury. They both have kind of the option for those better laptop GPUs that can really kind of handle this model. And if you're going to do it on a desktop variant, then they all pretty much can be equipped with the proper GPUs to support it. All right, so now that we've gotten a couple of those things out of the way, we can go into kind of the getting started here. And really the important stuff to talk about here is installing kind of the proper software. Z by HP has a really pretty nice offering here that's open source and available to download, which is the Stack Manager. And that basically you can kind of install and know that things will work together, the different packages that you click in and install there, and kind of get started fast. If you want to install stuff yourself, you can also do that, obviously. The required libraries for this will be PyTorch, diffusers, transformers, OpenCV, and FTFY. I think the ones most people will know will be PyTorch, and then really diffusers and transformers are kind of out of they're open source out of Hugging Face, and really kind of help you to work with diffusion models and transformer models. And then OpenCV for computer vision, and FTFI for Unicode issues. And after you have those required packages, you're basically going to need to download the model. And I've used for this demo the version 1.4, and I think version 1.5 is just recently out. So you could check that out. But if you want to kind of follow along with the seeds and the examples that I have and recreate a lot of the stuff that I have, then something like 1.4, this here, Stable Diffusion 1.4 should be what I used. And you basically need to create an account on Hugging Face and log in, and then you can download that model checkpoint. So the other piece is that really makes working with Stable Diffusion a lot easier is called Stable Diffusion Web UI. It's a GitHub repository, and I think has quite a few different contributors, but the link is down here on GitHub, and then it's automatic 1111 Stable Diffusion Web UI. And you get kind of a very nice view with some sliders, kind of a dashboard here that you can kind of trade and tweak all the different values and variables. And this really is how I interact with Stable Diffusion most of the time. I think it just makes life a lot easier to have a lot of this stuff. You can see even down here, you kind of have something that tells you kind of how long it took to run, as well as how much memory is being used, and like the prompt and how many steps you're running something for, the sampler you're using. So if you want to be very consistent with kind of logging all of your info, you can basically just copy and paste something like this every single time you're running a different version of any of these things, and you can kind of collect the seed and get the reproducible results out of the model. And so yeah, this is really helpful. This is the text to image view. There's also an image to image and an upscaling view. So really, this web UI is kind of my number one suggestion on getting started and a useful tool for Stable Diffusion. So we'll now get into a section of, let's say you've set up Stable Diffusion, you kind of have the required packages, and you're really trying to understand, okay, what does a good query look like, and how do I maybe improve upon a query or an image that I've already created? And so we'll go through some tips and some tricks and kind of techniques, and hopefully give you a little bit of a better idea on how to take your queries from kind of basic to a higher level. And really, here's kind of a couple of small tips. First thing would be to start really simple. So if you have kind of a general idea, you can put something in and just start generating images, see what out of your query the model's picking up, and kind of maybe what it's not picking up, and try to maybe adjust from there. The next thing would be really logging your seeds parameters, any input images you use, so that you can reproduce your work. I think treating Stable Diffusion in kind of a scientific way will help you to not only grow in your ability to query things, but also just to help you with, let's say you created a really cool image and you clicked rerun, or you changed the query a little bit and you want to go back to it. Then if you really kind of log your work well, you'll be able to really reproduce any of the images you have directly out of the model. This could be maybe also important if there's some sort of question as to how you came to create the work that you created. And so I think it's important to just really keep those notes there for reproducibility. And then, as you start to get more familiar, I think, and if you have a better GPU, running with additional kind of details to the query, as well as higher batch size and counts, can really help you to pick out a good or great image out of maybe a query that you had that's pretty good. But if you run it with a bunch more seeds, you can kind of get some variation and see some interesting results. Along with that, maybe some of those more details that you'd add would be a style or an artist. So those basically are great at kind of helping to change what that output will look like. In the style of Vincent van Gogh will be very different than in the style of Thomas Kincaid, for example. And really, kind of there's plenty of stuff to play with there, and most of the artists or styles that you're familiar with, unless they're quite niche, should probably be available to you to use in a query. And those will really help find to kind of what you're looking for in the model results. You could also add things like material information, if it's a painting, if it's a sculpture, things like that. And I think one component to understand about Stable Diffusion as well would be prompts where you're expecting some sort of legible words, maybe like a poster or something like that, are going to be very hard to do in Stable Diffusion. It doesn't really create something like a word very well. It'll create maybe a bunch of A, B, C, the actual letters, but it won't create like a legible word. And so those are probably better done in a tool like Photoshop after the fact. If you want to have, say a poster, you can create the image, but then do some post processing on top of it to add words. And another piece is you can do something called kind of interrogating an image. So you can import an image into the Stable Diffusion web UI, and basically you run interrogate on it, and it will give you its idea of what a prompt would be to generate a similar image. And so if you're looking to kind of get examples of maybe how detailed the prompts can get, or different artists to use to get something similar to an image, this is a great way of kind of understanding a little bit of how prompts work and how to build stuff. Another tip would be to kind of use a workflow similar maybe to something like a genetic algorithm, where you can start with a text to image prompt, pick your favorite out of that text to image, and then start fine tuning that in an image to image conversion. And really kind of each cycle that you run through, you can maybe mask out an area of the image you don't like and ask the model to fill it. You can maybe, just pick your favorite image of the 8 or 20 or however many images you generate, and use that as kind of the starting point for another um, view with maybe the same query or a slightly tweaked query. Really, this is kind of where a lot of the fine tuning of any of your results will come. And it's kind of what makes, to me, Stable Diffusion a lot of fun to work with. And also, then kind of with the image to image, you can really play with denoising strength, which is how much the image to image algorithm focuses on the input image versus the text input. And so you can basically, with a lower denoising strength, kind of make some light tweaks, or a higher denoising strength, take maybe the concept that's shown in the image and really put it in a quite different environment. So that denoising strength is a really powerful tool, and for whatever you're trying to do, you're going to probably have to play around with it. Maybe start with a little bit higher, and then as you start to get an image that you're enjoying and kind of want the composition to pretty much stay the same, you can move it lower and have some slight tweaks to it. So here's a couple of examples we'll get into of kind of what the input text and maybe what the output are, or for a workflow that I used. This image actually used in this slide deck. I think if you're paying attention, you may have already kind of noticed, but all of the transition slides have some sort of artwork, and that artwork was all generated in Stable Diffusion. So if you're looking for how to replicate an image like this here, I have the seed, the sampling steps, sampling method, and other variables that are useful to kind of recreate this image here in the Stable Diffusion version 1.4. And so my input text for this was robot standing in frontier landscape, looking at the horizon, painting. And you could really see basically, okay, here's a robot, kind of looking out into an area that, has a bunch of hills, and, is it painting? And if we want to interrogate it, we could see what is the, query that the model thinks could generate, a similar image to this. And it's a robot standing in the desert with a person walking by it, sky in the background with clouds, and a person walking by it. So you may see, in this case, it's picking, maybe this little red dot here as a person, and it's, repeated that twice. This is a piece with some transformer models where it's, not a perfect sentence, but you can clean this up, but you can also understand maybe that you're, if you repeat things in your query, it'll pick up on it more. We'll go through another technique of kind of adding more attention to certain words, or removing more attention from other words. And then you'll see here is basically an artist, David A. Hardy, right? So it thinks this painting here could be most similar to the artistic style of David A. Hardy. So if you wanted something similar, and maybe you're kind of changing slightly, or kind of want something in a similar vein, you may add this by David A. Hardy and get more consistent results, or kind of that painting style that you like. Again, if you're looking for other artists, there's additional resources we'll have at the end that are kind of let's say guide of some of the artists you can pick to use in these models. Maybe we'll walk through now a little bit of a realistic example of kind of that second thing I talked about, of using almost like genetic algorithm of creating an input, running it through the model, and then picking kind of the best outputs to run back through as inputs. And so let's say I want a man riding on a motorcycle on a highway, beach in the background, and a painting. And so I run that through the text to image generator, and I get 8 different images here. And let's say I like this one on the top right the best. but I'm looking here and I see, okay, there's like some sort of motorcycle or, something I don't really want in the background. Also, maybe, as you look, this guy's helmet has something funky going on, some sort of maybe not fully finished design. But for the most part, like, looks like a pretty good base image. And from there, maybe what I can do would be to in-paint that area that had initially had that kind of item on the beach. And I'll basically, when you're in painting, you draw kind of a mask over the area, and then you ask the model to kind of fill that area, understanding the context of the other pixels around it. And you'll see basically we have a bunch of blurry components here, and I just picked the one that kind of looked, you know, decently blurred there, and we'll send it back to the image to image model after inpainting. Again, if you want to kind of follow these steps, we have the prompt, the seeds, and all the um, values that you would need to kind of recreate something like this. And so the next piece we'll talk through in this process is really around denoising strength. So I'll keep the input image and all the other variables pretty much the same, and really just change that denoising strength to kind of show how that really affects the model. So if we have the denoising strength relatively low, you'll see that blur is pretty much still in there. And maybe this one on the bottom is like the best one out of the bunch, but we really still see kind of that gray area instead of like a full white sand beach. And so we can, maybe take the denoising strength up, quite a bit, which will keep the same general concept, but maybe it will change things too much. Like now we have what looks like a bunch of different sticks in the ground, and maybe we have a runner running by, and some people on the beach. We have maybe some stuff that we don't want exactly. If the denoising strength goes too high, it gives the model a little bit more freedom in terms of kind of how it sets the composition. You can see there's now like a boat or maybe an island, off the coast. And so maybe what we want is something in the middle. And, this here, the blur is out of this image. And really for most of the images in this, denoising strength of 0.4. And we can see, okay, if we go too low, the blur kind of remains. The image is pretty much almost exactly the same as the input image. If we go a bit too high, we're losing maybe some of the composition details that we created. And so we can kind of dial it back a little bit and pick something that we're going to be happy with. And so, this is maybe the output and end result that I was looking for, kind of a clean beachscape with a man on a motorcycle, riding by it. And so this, for this example, may be exactly what I was looking for. If it wasn't, maybe I can, maybe I want a full rider. What I could do would be to outpaint. So you basically kind of grab a section of the image and ask Stable Diffusion to fill in whatever that rest of the image. So if you wanted the full rider, you could do something like that. And next, we'll kind of hop into another view we can look at for optimizing queries. This is pretty new. Again, this is actually open source out of Google, and it's called Prompt to Prompt. And they have a GitHub repo with it. But you can basically see this is for editing some of the attention that certain words are paid. So you can, take the boulevards are crowded today and make them slightly less crowded, or take a prompt that generates an image and add slightly different context to that same image. So really, it's a pretty cool view with how the prompt to prompt works. It takes the prompt and edits the attention throughout, and they have the ability to add or subtract words, as well as the ability to kind of like increase the attention or decrease the attention that certain words are paid in that input prompt. And so, yeah, again, if you want to read the article, here is prompt to prompt image editing with cross attention control out of some folks in Google research. And again, the source for the GitHub is in the slides here. Really cool new tool that can kind of be used for really that fine tuning of a query with Stable Diffusion. And maybe one of the other things to look at here would be the concept of a prompt builder. I think this is probably more useful for people that are just getting started, but basically it's a kind of visual block by block builder of some details and maybe some hints for artist style. It's a drop down, so you can just click things and add it. You can kind of see examples and really maybe go from there of understanding it. And yeah, so you can kind of see, here's the link for it. I think if you're just getting started and don't really understand much about Stable Diffusion, this might be a great place to really get started. We have additional resources here. The slides will hopefully share at the end, so you can just click on the links. If not, you can transcribe them from the slides here. But we have a couple of different galleries, and then that prompt to prompt view, the prompt builder view, and then this prompt book, which was built for DALL-E 2, but works really pretty well in terms of understanding how to create queries for Stable Diffusion as well. So we're close to time here, and we'll run into a little view here of maybe some examples of how you could use Stable Diffusion in a real world workflow. And I had an idea here of potentially what a Stable Diffusion powered photo booth would look like. And so in my view, it would take an input image, which is taken from a camera, and have a component here that is basically interrogating the photo, but maybe with a ability to tweak this last component of the artist that it's by. And so a portrait of a man, by, and I showed a couple of different options that could maybe be useful to understand kind of the difference. And so, by Picasso, by Da Vinci, or by Grant Wood, and you see the distinctive artist styles out here. And I think this could be, something where if someone spent a bit more time on it, could definitely be a really cool application of Stable Diffusion, something that the average person could maybe select the artist, take the picture, and get one of these outputs, back in maybe 40 seconds or 50 seconds, whatever the time it takes to run. But really, maybe a cool idea for people to kind of further work on. The next view would be something that people have already done, which is basically Photoshop plugin for Stable Diffusion. So how this is mostly used, I think, is basically people will create some sort of image in Stable Diffusion, and they'll be able to edit it in Photoshop, send it back to Stable Diffusion, and kind of make some edits, and then continue that loop. So it's a bit more control in terms of the elements that come from maybe one or from multiple images in a round. If you're creating 8 images in a set, you can pick maybe the best elements that you like the most. So if you think of that rider we had, you can maybe pick the bicycle or motorcycle from one image, and you could pick the beach or sky or the clouds from another image, and kind of pick the best in Photoshop, put them together, and then send them back into Stable Diffusion for some slight tweaks or some blending. Really, I think this is a really cool use case for how Stable Diffusion is used. And the last thing is somewhat recent news here, where Shutterstock is going to be using the DALL-E 2 model to create uh, work for basically any of these stock images that people search for on Shutterstock. And you could do something very similar with Stable Diffusion, right? So picking kind of the best of any of the queries. Shutterstock obviously knows what a lot of users are looking for, and so that may be some ability for them to work with. But I think also just having a user be able to input kind of whatever they want, be able to pick out some stock images and use them in their slides, similar to kind of how I've done for my presentation here of taking kind of an abstract idea, adding it to a slide, and having um, that ability to basically really enhance any of your slides or presentations without having to go through the time and effort of fully building out the composition, taking the photos, that sort of thing. And you may recognize this image here as one of our example images, but we'll hop through the last section here, which is kind of what's next for this space. And in this, I think the big elephant in the room for what's next is going to be uh, videos that are kind of created in the same way that uh, Stable Diffusion creates images. You can see an attempt here to use Stable Diffusion models that kind of blend different concepts. So you have like a bowl of spaghetti with strawberries versus with blueberries, and they kind of blend together. This is maybe a more primitive view, but if you look at what Google research and what Meta are doing, there's kind of pretty impressive examples of prompt to videos, especially here looking at the text in this image. Out of image gen is out of Google, and then make a video is out of Meta. And you can see again kind of maybe where the next steps for these sort of diffusion models will come from, and I think it's very exciting. So with that, we will wrap up, and if anyone has questions, feel free to type them in. I should be on during the presentation, so I hopefully can answer some of your questions. It's been awesome giving this talk, and hopefully you all feel a little more comfortable with the concepts of Stable Diffusion. And I think the big thing, if I can give you a kind of call to action, would be go out, download the model files, really play with it. And I think that's where you'll get really kind of better results. Is you can take in the things that I've kind of given as tips, but you can also obviously learn more. There's plenty of information, videos, and resources out there online. But I think the way you'll get better with any of this is just by having an idea and then trying to walk through from kind of an idea in your head to writing a good prompt to picking kind of good images and maybe fine tuning those images. So having a real project that you work on for any of these things, I think, is the best way of learning. So thank you very much. Bye.